Hello, welcome back. All of our programs up until now have pretty much fit on one page, and you probably know that these software systems are going to be much bigger than that. As we get going, we're going to need a way of managing the complexity, and one good way of doing that is to break things into modules or decompose the problem into modules. And that's what this segment is about. We'll look at the syntax and the semantics for writing functions in the C language.
Well, as our programs become more complex, we're going to have to figure out a way to divide the problem into bite-sized pieces. And all languages have a way of doing this, of dividing the problem into some sort of functional modules. And in C, these modules are called functions. Our programs up until now have been using one function. We've been defining one function, and it's called the main function. Of course, that's the entry point for all C programs. All C programs start executing in the main function. We've been using other functions without really talking about what we're doing. We've been calling the scanf function and the printf function. Well, let's start this discussion of functions by talking about a chart that you might recognize. It's called a hierarchy chart, and it's a way of modeling many complex things that we talk about. And one place that you've probably seen this before is in a corporate organization chart, where the president is at the top and the vice presidents are beneath that person, and maybe managers are beneath the vice presidents depending on the organization. So a hierarchy chart is a good way of representing the concept of abstraction. In abstraction, we have an issue of how much detail is presented at each place. So the president of the corporation can't possibly manage the detail of all the employees in a large company, so the president has an abstract view of the company, which is by communicating with the next layer down in the hierarchy chart. So in this slide we see that C programs are also going to be divided into a hierarchy chart or represented in a hierarchy chart, and we say that the main function is always at the top. So the main function can call other functions or invoke other functions which return to the place where they were called from when they're finished doing their work. So when you call printf function, what happens is some other C code that you can't see is actually executed, and then when its work is done, you return to the main function and take up where you left off. We can define our own functions, and when we were writing a program for taking an order in a restaurant not so many segments ago, we could have divided that up into sub-functions, and it would have made a more abstract and a more readable and reusable representation of that solution. Well, we didn't know how to make functions at the time, so some people wrote code that was many pages long, and I'm sure you experienced that the program starts to get hard to work with when you're scrolling up and down trying to find the place that has the bug in it. So as a rule of thumb, your functions in C should be less than a page long. If you start to get really long functions, it will become difficult to work with. Functions are never defined inside of other functions. So this is a common beginner's error. Defining a function inside of the main will never compile, and the compiler errors are quite confusing. So as you're deciding how to design your system in C language, you might start by drawing one of these hierarchy charts, and when you go to implement this, some people would prefer to implement from the top down, and some people prefer to implement from the bottom up, which means you would actually work on the functions that are at the bottom of the hierarchy chart, the most detailed ones. Both of these are legitimate ways of making programs. A top-down approach is the one that's most favored, and especially if you kind of know everything that the system is going to do, then a top-down approach turns out to be quite a bit more efficient and easier to work with. So as we get close to defining a function in C, let's start off by saying that a function has to have these three things. A return data type. This is what the function call will evaluate to. The function has to have a name, and it has to have a parameter list. To really understand these, what these are doing, it just makes sense to go into the development environment and show you how to make a function that has these three characteristics and how to call a function, and well, it's just easier to show you. So let's go and do that now. Okay, in the development environment I've created a new project called Functions, and I've made this beginning project. So the first thing we want to do is to just make a very simple function and call it. So in the main function I'm going to call a function that is called welcome message. So when you call a function, you name the function, and then you have to have these parentheses at the end, and it's a C statement, so the semicolon at the end. So there's the simplest possible function call, and we're going to define the function outside of the main, and we'll define it above the main. So recall that there are three things that are required for a function, and the first one is the return type. This function that we're defining, the simplest possible one, doesn't return anything, but it still needs a return type, so I'm going to make it a void function, and then I'll name the function, parentheses here, and an open and close brace. So this is the function definition, and inside the function I'm not going to do anything too interesting. I'll print out a couple of messages. I'm inside the function, and a welcome. Welcome to learning functions. So there's a function that doesn't have too much value, but we can think of it as, well, this detail of what's in the welcome message is now not in the main function. So I'm going to set a breakpoint right here, and let's compile this first and make sure that there are no typos. Okay, so the simplest possible function, it doesn't do anything except print out a couple of messages. Let's run this in the debugger so that we'll make sure that we understand the flow of control when we have a function. So I'll push F5, and we're going to run to that breakpoint. Now, if we execute this whole line of code, which would be a step over, it would jump into the function, execute the whole function, and then come back. But what I want us to do is to use the debugger to watch the flow of control when we call a function. We're going to step into that function. So we have this button now. It's or you can use the F11 key. If you step into that function, look at the yellow arrow. It shows that we're now going to execute inside of this function. It will print out this message, it will print out this message, and at the bottom of the function it comes back to the main. So the function call says, go and do everything that's inside of that module, and then come back here. So there's our simplest possible function, and I've defined it above the main, and that's kind of important. For now, we're going to define our functions in the reverse order that they're used. So the first function to be called is the main function, and then we jump over to the welcome function, and then come back and finish the main. And there's the result of calling the welcome message function. Well, let's make a function that does something a little bit more interesting. I'm going to make a function that takes a value and returns a value. And you don't know what that means yet, so I'll just show you. I'm going to declare an int variable called returned value. That's what the function will give us back. And just a simple variable called a, and I'll put 10 in it. Now I want to write a function that will find the cube of a. Well, I could just write a times a times a to get 1,000, which is a cubed, or I could define a function to do it for me. So I'm going to say returned value gets cube the input, and I'm going to pass in a. Okay, so this is the function call, every function call has parentheses, and inside the parentheses you can specify the arguments to the function. This function call didn't have any arguments, but we still had to put the parentheses. And this function call actually evaluates to a value. We want this to evaluate to 1,000, which is the cube of whatever we passed in. So this function call evaluates to 1,000, and then we can assign that to a variable. Let's define the function first, and then we'll go and see how it works. So the return data type in this case is not going to be void. It is going to return something useful, and its return type will be int. Now the name of the function is cube, the input, and now we're going to define the parameter list. The parameters to the function are what gets passed in, so the parameter list needs a data type as well. So I'm going to say this function is expecting the user or the caller to give it an int, and I'm going to use my standard way of writing a function, declare a variable called result, and then down at the bottom return result. And then in the middle of those, calculate the result. Result gets, for this cube function, input times input times input, and then return that. So that function looks correct to me. Now let's think about everything that we've done here. I'll move that breakpoint and put it down there. And I'll compile this to make sure that I haven't done something wrong. Okay, so we have, this is the function call, and this is the function definition. Let's run to this breakpoint. Okay, what's in the variable a? That's simple. We have 10 in the variable a. And we're saying that we're going to pass a into the function, or the value of a, which is 10. So where does the 10 go? If we step into this function, the 10 goes into this variable called input. You can call these whatever you want. This variable is local to the function. So as we start to execute this function, execute one line of code at a time, well, there's only one executable line here. We take the value that was input into the function, we passed in 10, and we cube it, 10 times 10 times 10. So we can see that the variable result has 1,000, and we're going to return that result. Well, this is the return data type. The return data type is int. So we're going to return 1,000. Think of it as going back to the caller through the return type with this value. And the value that we have is 1,000. So if we step, we'll find ourselves back here, and this function has finished executing, but the assignment hasn't happened yet. So we have to execute the rest of this line, and now returned result has 1,000. So think about the power of what we've done here in just a few lines of code. We've defined a function that we can use over and over that takes a value as its input. Whatever we give it, it will give back the cube of that value that we passed in. So this is the function call. This is the argument to the function. The argument matches the parameter in the definition. And this is the return type. So this function returns an int, and it takes an int. You might guess that we can use any data types that we want, and this is a functional module, or a function in C. Let's go back to the slides now and talk about this, the theory of this a little bit more. Okay, we're back having looked at making a function in the development environment. Just to review, when you define a function, you must define a return data type, even if that type is void, meaning that it really doesn't return anything. You need a placeholder there. And then a function must have a name, and a function must have a parameter list. Even if the parameter list is empty, you signify that by making parentheses that have nothing in between them. So we've made a simple function, and we're going to keep talking about this. You pass information into the function through the parameters, and each of the parameters has a data type. So in our small function called cube, we had, or cube the input, I guess we called it, you had one function and one parameter, and its data type was int. So that was the information that main was passing into the function. Information can be passed back from the function to the caller through the return type. So we executed a return statement inside of the function, and that return statement says immediately go back to the caller with this piece of information. And we looked at how to call or invoke the function by using its name. Now here at the bottom of this slide is the general form of calling a function that takes two parameters and gives back one piece of information. So if we write z gets function of x and y, we see that x and y are the values that we're passing into the function, and the function call itself will evaluate to whatever value is returned. We take that and we assign it to the variable z. You might recognize this syntax from a math class if you've ever taken a math class that involves function calls, and these are the students' least favorite things to work on. When you have y equals f of x, it's the function that's processing the x to result in the y. So you can think of this as we have a function that processes the values x and y and gives back the value that we'll put in z. So it's not quite the same thing as the mathematical equivalent, but that's where this syntax originated from. And now just a brief summary of the concepts that we've talked about in this segment. Dividing your programs up into modules is really important. It allows you to get to the next level of complexity. And we organize our C programs by making a hierarchy chart. Hierarchy charts are used to organize almost anything that's complex. We think of it as the whole, and then the parts, and then the parts of the parts. We've already been using functions that someone else has defined, particularly scanf and printf, and we looked at how to define our own functions. The reason to define functions, you want to divide and conquer the problem so that you can solve more complex problems. As a rule of thumb, your functions in C should be less than a page long. And there's people who disagree with that, but let's start out with that as a rule of thumb and go from there. There might be reasons why a function needs to be longer than a page. Functions should be defined to achieve one objective, and they should be named accordingly so that you can read the code more easily. In the next segment, when we define some functions, it will be much easier to understand why that's important. If you have a bunch of functions that are named inappropriately, then it doesn't add anything to the readability of the code. If you can't understand what the code is doing, it's just very frustrating. So here's the general form for defining a function. You have a return data type, the name of the function, and the parameter list. And then inside the braces, the body of the function. This is what the function actually does. So recall that the parameters are the input into the function, and the function returns one piece of information back to the caller. The general rule for calling or invoking a function, you mention the function's name and you pass in arguments. So the number and type of arguments that you give to the function must match the number and type of parameters that the function is defined to have. Does that make sense? If you define a function that has two parameters, when you call it, you pass two arguments. And the function call itself evaluates to whatever that function returned. And you can use that value, for example, in an assignment statement. And that's the most common form that you'll see it. So in the general form I'm showing here, we have returned result gets function name and pass in the arguments. Well, this is your introduction to modularization or functions in C programming. I hope that you're enjoying it. We're going to use these in the next segment.